action.
I have a stupid question.
There are no stupid questions. What's up?
Can we make sure to do problems with the T table? Because that's something I've been struggling with.
Okay.
Okay, I just wanted to let you know.
Yeah, that's good. I have one in here. We should be able to get some of that action.
Thank you.
Yep. Okay. All right. Delaney, you haven't missed anything. We just are getting started right now. So Dwayne thinks his cleaning business is in the top 10.3% of all cleaning businesses for revenue. If cleaning businesses follow a normal distribution of $500,000 revenue with a standard deviation of 5,000, what is the minimum revenue Dwayne's business would have to achieve in order to be in the top 10.3%? Okay, so I give you just a couple seconds while I get my, whoa. My stuff set up here. Okay. So, Nick, what do you think? What type of problem is this?
Well, it's definitely not single value X. I know that.
Okay. What makes you say that?
I don't think it is. Just with all the different what do you think? Actually, it might be with normal distribution. Hold on a second.
Okay, so while he's looking that up, Travis, what are we trying to figure out? You're on mute.
Yeah, just I don't want you guys hearing my sister's class.
All right.
We are trying to figure out what the minimum he needs to make to achieve that top 10.03%.
Okay. So, Delaney, does that sound like a single value, or what does that sound like?
Okay, there we go. I'm gonna say I think it's a confidence interval.
I think it's a confidence interval. Okay. Nick, what do you think?
I think it is a single value just because there's normal distribution.
Okay. So it is a single value. I mean, everything we're going to do follows a normal distribution, but
Right.
it's just, it's 1 point. Okay.
Right.
So
Only one. Yeah.
So let's draw this. Okay. And here in the middle, what value is going to go right here, Delaney?
In the middle is going to be 500,000.
Okay, good. Okay, so Nick, back to you. When I draw a a vertical line.
That's what you want. That's what you want the 10% to be.
Yeah. So where do I want to put that vertical line?
You want to put it where you are right now, to the right, just the top 10%.
Okay. So I'm trying to figure out this.
Yeah.
Okay, good. That is correct. All right. So how would I go about doing that? So I want to find this value right here, X.
Right.
Okay, that says that would be the minimum value or greater, essentially, that Dwayne has to achieve in order to be in the top 10.03%. So, Travis, how would I proceed?
Would you, instead of doing, you would do X bar is equal to, I guess, the Z score multiplied by standard deviation plus the mean.
Okay, I like everything you said except for X bar, because we're just dealing with single value X.
Okay, just X.
And
just
X, but the formula you quoted was correct.
Okay.
My pen gets possessed every now and then. So we're going to eventually, We're going to eventually use this formula. So how do we determine what Z is?
Wouldn't you do, you'd go into the Z table and then you'd find 1 subtracted by 10.03?
Yeah. So what I take 1 and subtract it by what?
The 10.03, or would you subtract it by, yeah, by that number?
So do something with that 10.03.
Uh,
You're on the right track, man. Just do something with that 10.03.
mm,
Whenever I have a percentage, what do I want to do with it?
Turn it into a decimal or
Turn it into a decimal. Nick, how do I do that?
Would it be? Would it be? Would it just be 1003?
1003?
Yeah, 0.1003. I'm sorry.
Yeah. So I take 1 minus that. What is that? 0.8997 or something like that?
1 second. Yeah, it's 0.8997. Yeah.
Okay. So I'm going to go to my Z table and find that number.
It's 1.28.
Okay. Everybody see how we found that?
yeah.
Travis, you see how we found that?
hmm
So let's see here. Right above where my cursor is now, 0.8997. We go back over here, grab that 1.2, and we know we're in the 0.08 column. So our Z score is 1.28. Okay, so I have Z. I have sigma, which is 5,000. And I have the mean, which is 500,000. Okay. So that's how I figure out the minimum he would have to achieve to be in the top 10.03%. Everybody good?
Yeah.
Okay. So again, in my opinion, if you see something kind of odd like this, that's usually me trying to make it even for you so you don't have to extrapolate values on the Z table. See? So it's kind of a tip that, okay, I have a probability. I need to go in and find a Z value for that. Obviously, we want to determine if it's single value or sample mean, but there's nothing in here that talks about sample mean or X bar. So we're indeed going to use that formula right there. And then drawing a picture helps because we know this is going to be well above 500,000. Okay. That's going to be a little bit more than 5,000. That'll probably be about six and some change. So it'd be 506 and some change.
Yeah, 6,400.
Yeah. So good. So it all makes sense. It's all congruent. Nice, happy, clean problem.
So then it's just the revenue would have to reach $506,400 for it to be in the top 10%.
Yeah, he would have to make at least that. He might make more, which would put him out here.
Right.
Okay, so he'd be above that, but he'd have to be at least that in order for that all to be true. Okay, and him to be able to make that claim, so to speak. Oh yeah, I forget what I remember what I was going to say. Let me just do this. So with this, what I could do is some kind of Excel function. I don't know. I'm not going to do it right now because I can't remember it off the top of my head, but I could take the 1 minus of this, put it into Excel to figure out what that Z-score is. So I could save myself some work there, but it might just be more confusing than anything else. Okay. All right. This one's kind of tricky. So we're moving up a little bit. All right. Kirsten manufactures windshields. Windshields follow a normal distribution with a mean of 1,000 pounds per square inch and a standard deviation of 100 pounds per square inch. Kirsten's standards for windshields require sample means to fall within a symmetrical interval that is 79.60% around the production mean. Again, another interesting number. Okay. Rachel measures 25 windshields and gets a sample mean of 855 pounds per square inch. Should Kirsten continue or stop production? Okay, so there's a lot going on here. All right. First things first, Delaney, what type of problem do you think we're dealing with here?
Would this be a sampling?
Yep. Why do you say that?
Because we're being given the sample mean.
Yep. So we're given a sample mean. And really what's happening is Rachel is taking a sample mean to see how things are going. And if these windshields that are coming off the assembly line are meeting the standard. Okay. And Nick, are we dealing with a sampling proportion or a sample mean kind of X-bar problem?
Wouldn't we sample mean like the X-bar problem?
Okay. It is. All right, because there's nothing in here about proportions.
Right.
We have a mean, we have a standard deviation. Okay, so there's nothing in here about proportions. So Travis, what's another thing we could do next?
We start setting up the problem.
Okay. How do we want to do that?
It'd be X equals X bar minus the mean over standard deviation. Or is it the other one?
Well,
I
let's
think
do
you're right.
something first. Let's draw this.
Okay. Oh,
and
okay.
just kind of think about what we're dealing with. All right. Okay, so there's our mean. We know that that mean is 1,000. Okay. And what this is all acceptable windshields. So that's going to go from here to here. And the area that is going to cover is 79.6% or 0.796. Right?
Yeah.
Okay. So, Travis, between this blue area here and this blue area here, first of all, regardless of what the picture looks like, is this equal to that?
Should be.
Okay. Why? Why do you say that?
Well, if the graph is 76 or 79.6, it's split evenly. It's a I'm trying to figure out what it's a symmetrical interval, pretty much.
Yes.
So both sides should look the same.
Very good. Okay. So, Travis, what does this area plus this area equal?
That should equal 20.4.
How did you get that?
I kind of added till I got to 1, but you can subtract.
Okay. So 0.204 or 20.4%. So Nick, how do I determine what percent this one area is going to be?
Then you would just divide 0.204 in half.
Yep. Which is what?
0.102.
Okay. And Delaney, what do I do with this number?
So then it's going to be the same on the other side, 0.102.
Yeah, it'll be the same over here. Okay. And what I want to find out is I could call this X bar 1 and X bar 2. Actually, I don't even need this side. Travis, why don't I need to even do anything with this side, do you think?
Because once you find out the one side, you can pretty much find out the other side.
That's true. What else do you think? Nick, why do you think I might not even need to do anything with this side?
I mean, because as long as you solve one of them, you're gonna get the answer, right?
Yeah. Even more specifically, look at this. Rachel measures 25 windshields, gets a sample mean of 855. What I'm trying to determine is if 855 falls in here or falls out here. 855 is not going to fall over here.
Right.
Oh, yeah.
See what I mean?
Yeah,
So I'm
'cause
creating
when you look
extra
at
work from. Go ahead, Travis.
Because when you look at the data, the mean is 1,000.
Exactly.
1,000, it's less than 1,000.
Very good. So all I'm concerned with is, does 855 fall in here or outside here? I don't even need to do anything here. And I'm kind of might be saving myself some extra work. So really all I need to find out
Is X1.
is this value right here and how it compares to 855. Okay. Is it 854 or is it 906 kind of thing? Okay. So how do I determine what X1 is, knowing that this area is 0.102? I'll give you a hint. This isn't really too different from the problem we just did at this point. What's anybody think?
Could we just find the z-score?
Yeah, how do we do that?
We could just look at the table, right?
Yeah, let's go to our table. All right, so we're looking for 0.102.
Negative 1.27.
Yeah.
I just saw it. Negative 1.27. Looks right to me. Everybody see that above my cursor there?
Mm-hmm.
It makes sense that it's negative because we know it's to the left. So everything is working out well. Okay. So if we know that Z is negative 1.27, Delaney, what do we do now? We need a formula that solves for an X bar.
Yes. So the formula for that is going to be X bar equals Z multiplied by the standard deviation over the square root of n plus m.
Okay, super. Good job. Okay, and let's see. We have z, negative 1.27. We have sigma, which is 100. What is n, Nick?
855. No, that's wrong. Oh, whoops.
It's okay. Better to make the mistake here. That's what this is all about.
Oh, I don't
Okay.
even know why I said that because I literally remember doing a problem just like this too.
That's okay. Again, it's better to make it here than tomorrow. All right, so n is 25. And then what is the mean, Nick?
1,000.
There you go. All right, so we know that this is going to be less than 1,000. Travis, what's that computation?
Yeah. I got like 974.6.
Okay, so 974.
Or negative. It should be negative. My bad. Oh, wait, no, it shouldn't. I'm so confused.
Now, it'll still be positive. So 974. I think that sounds right. Let's just assume it is. So Delaney, if this value here is 974 and the sample mean is 855, should Kirsten's continue or stop production?
She should stop.
Okay, remember that if I ask you a question why, that doesn't mean that you're incorrect. So why do you say that?
Actually, now I'm thinking she should continue.
Now you were right first time.
Oh, I was right for okay.
Yeah. So remember, Kirsten's standards for windshields require sample means to fall within a symmetrical interval in this white space. Okay.
Okay.
All right. So 855 doesn't fall in the white space. If that's 974, 855 falls in the blue space. So she should stop because something is wrong here.
Yeah.
Okay. Because again, too, that 855 is an average in the sample. That means there's values below 855. And so that means that probably what has happened is that the production mean, while it's supposed to be 1,000, somehow it has shifted to be less than 1,000. That's what actually is happening. So maybe a machine is out of whack or something like that, and nobody knows it, and they just keep on producing it, and the output has us down here. Does that make sense? Does that make sense to everybody?
Yeah.
So this part right here is a little bit more conceptual, but the main thing is if her standard is in here and she gets a result out here or even up here, then she should probably pause, check machines. Maybe there's a new person that doesn't know what they're doing and that's causing this or something like that. And to go on a short tangent for Delaney and Travis, this is something that the fishbone diagram, if you remember from TQM, that's the kind of thing. Travis, are you taking TQM yet?
No.
Okay. So I'll get off the tangent, but that's how we would proceed. But the main thing is it doesn't fall in here. It falls out here. Okay. Everybody good with this one? Questions? Okay. A little bit complicated, but again, if you know it, the fundamentals, which I think you guys are really showing those today, I like to say you can fight your way through just about anything. All right. Okay, Nick, this might be your T-table. Let's check it out. Arnold is curious how many people have quit working out since the quarantine. Let me get rid of all this, sorry. He wants to develop an estimate that covers 90% of the potential values for the proportion of people who have quit working out since the quarantine. All right. First thing he does an Instagram survey. 1,000 people respond. Out of 1,000, 455 indicate they have quit working out. All right. So before we go on, let's talk about what kind of problem this is. Nick, what kind of problem do you think this is?
It's definitely confidence interval.
Okay. Why do you say that?
Because we have isn't that the proportion population? Or I'm sorry, not population. That's just the proportion, like a sample proportion.
Okay. So are there any keywords that cue you to say? So do you think it's something other than confidence interval?
There we go. I muted everybody. Okay.
Well, now you think I'm wrong now.
All right. Don't second guess
No,
yourself just
no,
because
no,
I
no,
asked you a question.
no, you're right. You're right. Couldn't could it be sampling because it is a proportion?
Okay, so Delaney, what do you think?
Okay, so in here, I'm going to sort my publisher date. I go ahead.
I am thinking it's confidence interval because it has the proportion.
Descending order.
Okay, Travis, what do you think?
I'm gonna say sampling proportion because I feel like the confidence interval would say with a 90% confidence interval or something like that.
Okay, so an estimate, okay, that covers 90% of the potential values for the proportion of people. All right, so let's break this down. An estimate is the same thing as a confidence interval. Okay. So you might say I tricked you. I didn't mean to trick you. I just want to make sure you understand what a confidence interval is. Okay. Now, from there, what he wants to do is do a confidence interval for the proportion of people in the larger population. And that would be what I call P-pop. Okay. P-pop is the proportion, the population proportion. Okay, and here he hasn't really defined what that population is, but people in general, essentially. Okay, so it could be the people in the world. I mean, really at that point. Okay, and when we say, and so when we see something like this, folks, where it says estimate that covers 90%, I want you to think about that's a really good cue. What that's asking for is a confidence interval, because that's essentially the definition of a confidence interval. Okay, so we are in the confidence interval forest. We're going to be doing a confidence interval for P-pop, which is written like this. Okay, but before we jump to formulas, let's see what we have. So we're going to need P, which is the sample proportion. And Delaney, what is P? Based on what we have so far. So from this red line above, what is P?
Would it be the amount that indicate that they have quit working out?
Okay. So walk me through how we determine P. Okay, the 455 would be the amount that indicated they've quit working out. But we need to do something with that 455. What do we need to do with that?
Do we subtract it from the 1,000 people that respond?
If we did that, we would get the amount of people who haven't stopped working out.
Okay.
I'll give you a hint. This is going to be a decimal. At most, it's going to be 1. It's not going to be greater than 1. If it was 1, it would say 100 people, 100% of people have quit working out. So we know it's going to be less than 1. So
Well,
Okay.
this should be a decimal. What's up, Nick?
it's not about my what the heck's it doing? The screen's like super tiny for me now. I don't know why.
My TV. Some kind of hacker. One of these Yahoo intruders that is not here today.
No,
Thankfully.
it's like, what the heck?
All right. So Travis, what do we need to do this 455?
Go back real quick. See if I have it in my.
Okay. So proportion means it's less than 1. So if this is how many people, if this represents that 1,000, right?
Mhm.
It's like a giant pizza with 1,000 slices.
Would we divide it by 1,000?
We would. What would that give us?
I know. And then wouldn't we need to go to our T table or no?
Yeah. Before we do that, let's get the formula straight of what we're working with. So what is the formula for a confidence interval for the proportion population?
Is it oh, I'm gonna get this wrong. Is it P plus or minus the Z score? No, it's not that one, is it? Times alpha. No, I don't think it's that one.
What is that?
Is it that one? It is that one. And then
You tell me, warrior.
I'm sorry.
Be confident. Be
Wait,
confident in yourself.
wait, in the formula, are you multiplying by alpha half, or
No.
is it the Z alpha half?
It's the Z score for alpha.
Alpha half. I'm sorry.
It's a
Okay.
subscript.
All
Okay.
right. And then you multiply that by the square root of P multiplied by, or I don't, yeah, it's multiplied by 1 minus P over N.
Okay. So what is Z for alpha half with a confidence interval of 0.90? Or excuse me, a confidence interval of 90%.
0.05. Oh, I'm sorry. The Z score is 1.65. Excuse me.
And how do you know that, Nick?
Well, that's from like the Mike TV table hack thing.
Yeah. Everybody tracking?
Yep.
Okay.
Yep.
All right. So here, 0.45 or 0.455, whatever that 1 minus is. What is N, Nick?
455? No. Oh my gosh. That's wrong. Hold on. No, it is 455, isn't it? Wait. Why am I getting this wrong? This is simple. Yeah, is it? Oh, okay. Oh, so it's the total. Oh, all right. Gotcha.
Okay, so just double click it.
Yeah, it's 1,000.
And we're just supposed to check, make sure you've done this right. You should have mulberries partway down.
And P is that. Okay, so let's do these computations. I have them somewhere.
like when it prints.
Okay, so anybody, Travis, do you have the upper value for this?
No, but I can do that real quick for you.
Yeah, let's go ahead and do that. And then Delaney, why don't you take the lower value? So
Okay.
the P 450.455 minus all this mess.
Okay, so now, County will close that. Look at that. We're gonna open. Double click on it to open it. Okay, query is kind of like a table. People make it up, they can put more than one table, but it's kind of like.
Got it yet, Travis?
I think it doesn't look right.
Okay.
Wait, actually, 1 second. Let me try something real quick. I think I could have messed it up.
Are you doing it on a calculator?
Yeah. Okay, wait, I think I got it.
Okay.
I got 0.48.
0.48. Okay.
Yeah. Don't think that's right.
Do you want me to try?
Doesn't look really wrong. What'd you-
Well, or it's 0.480983.
Okay.
If you want
We'll go with that for now. Delaney, what'd you get for the lower value?
Okay, so I got negative 0.6574.
Okay. We shouldn't have a negative number for that lower value
Okay.
because, so something kind of went wrong over here.
Oh wait, can I say it or no? I think I got it.
Oh, I see where I messed it up. I put the divided by 1,000 inside the parentheses. Okay.
Okay, so here it says filter by selection. So go to your first Stephen. And section and just say equals Stephen.
All right. We get that lower value yet?
And you have to click on the Stephen one, otherwise it'll come up with a different name. And just say equals. So it kind of collapses everything that I own and Steve,
Yeah, for some reason my calculator is saying I'm making an error. I'm not sure why.
All right. Anybody else got it? I mean, I
Yeah.
can do it.
Oh, I think I got it. Is it 0.4? It's 4.4290.
That sounds right. Okay. I'm going to go with these values for now. I don't know if I'm assuming they're correct
Yeah,
based on this right here.
I got the 0.48092 for the top.
Okay. So when I go up here to write inside this blue box, I'm going to write my 90% interval, or excuse me, estimate for the proportion of people that have quit working out since the quarantine. What symbol goes smack dab in the middle here, Nick?
I don't know what it means, but it's the M with the. That sounds so. I sound so stupid saying that. It's the M with the line under it.
It's the what with the line under it?
Is it M with the line under it, or is that right?
What do you think, Travis?
I think it's called just mu. Maybe.
What do you think, Delaney?
Because then you put the upper and lower on the left and the right. I thought that's.
Yeah, I think it's the.
You put P minus pop.
You put this. That's what P-pop is.
Why did I say that?
Okay.
Oh,
That's
okay.
the center of attention. Here's the key word, guys. Remember that tattoo where I draw like this and this next to it? We draw this and this next to it.
Mhm.
Okay. This is a brother and sister relationship. So when I have P here, I'm using the sample proportion to estimate P pop, which is the population proportion. Okay. And it is the center of attention of my interval. What symbol am I going to draw right here, Nick?
The less than or equal to.
Very good. And what number is going to go here?
Oh, is it upper on the right side? Hold on. Just so I get it right.
Stop looking through your notes. Look here on the screen. Pick a number.
I just forget which one. Is the upper 0.4809 on the right side, and then the left side is the lower side 0.4. That would make more sense.
Okay. So this means that based on this sample proportion data, that the proportion of people who have stopped working out since the quarantine is somewhere between 0.4290 and 0.48089. That's what that means. Okay. Everybody good?
Mhm.
Now, let's get rid of some of this mess because I have a few more follow-on questions.
Type that in there. Okay, I could drop my arrow and pick one here, but I want more than 1 year, so I have to do it this way. So that should be anything greater than 2010. And fewer than 100.
Okay, so
Here, I have to do
Travis,
less
Mhm.
if Arnold, instead of having an N of 1,000, he had an N of 2,000,
is above.
Mhm.
what would it do to this value?
Okay, now it says apply.
What would happen to that value?
Okay, so we have greater than 2010.
Wouldn't it?
And less than 100.
It would decrease.
Why do you say that?
I say that because I feel like if you add more, the survey or the graph would get stretched out, and when you condense it, it'll condense the graph pretty much. When you, if like you were to take 1,000 and like only take a sample of 500, if that makes sense.
Yeah, but it's actually the opposite.
Of course it is.
So let's say this line here is with an N of 1,000. All you got to do is stand on your head and you'll be good during the
Mhm.
exam. Just think opposite or put your clothes on backwards or I'm just kidding.
Yeah.
All right, so everybody check it out. This line here is for N of 1,000. And we have, when we do 90%, okay, we get that hack mark here, that hack mark here. Everybody good so far? That's what we've done. This hack mark is this value. This hack mark is this value. Now,
Mhm.
let's draw the curve for N of 2,000. That curve is going to be lower down here and higher in the middle. Like that.
Wait, so I don't want to jump in, but wouldn't the lower value would increase and the upper value would decrease?
Mhm.
Exactly.
I know you kind of just explained that. I'm sorry.
It's all right. It's better to hear you say it. It's about you, not me. So Nick is correct. Well, to get 90%, because this goes up, this value is going to go in here. It's going to increase, like Nick said, and this value is going to decrease.
Mhm.
Okay. Remember, sample size is king. All
Mhm.
right. and we get a greater sample size, we're going to get more narrow, okay, which means we're going to get a better estimate. Okay, so this might go up. I'm just going to make up values like to 0.44, and this might go down to 0.46.
Mhm.
And there we have a better idea. See how big this kind of guess is? But with a greater
Yeah.
sample size, we can narrow in on just exactly what that proportion is. Okay? Everybody good with that? Delaney, you
Yeah.
good with that line of thinking?
Yep.
Super. Okay. Now, let's look at this one right here. If Arnold stayed with an N of 1,000, so I'm going to erase my red line. Or no, I'm going to erase my blue line. Sorry about that. Actually, I'm just going to draw the whole thing over again. It's just too much hassle. Sorry, Charlie. Okay. So, anybody pick up that Arnold is modeled after Arnold Schwarzenegger? Maybe not. All right. So Arnold has an N of 1,000. Okay. And he did 90%. So he has some line here and some line here. And that equates to the black values up here. These values over here. Same.
Mhm.
So he's going to stay with that. But instead, he's going to do an estimate of 95%. Okay. So, Delaney, what would happen to this value? Would it become more or less?
So that would decrease
Okay. Why do you say that?
because if it's going up to 95%,
Okay. Remember, just because I asked you doesn't mean you're incorrect. So 95 would be fatter, right?
yeah.
I'd go farther out this
So
way.
yeah, it's going to decrease on the
Yep.
low.
And then what's going to happen to this value?
And then that would increase.
That's right. And think about it, folks. Remember, for the 90% formula, I use a z-score of 1.65. For the 95% formula, I use a z-score of 1.96. So that forces me to go out farther. See what I mean? So it all makes sense. So if I went 99, it would be even farther out there because I have a z-score of 2.58 or negative 2.58. Okay, that forces me to be fatter. Okay, and remember, I guess it depends on what you want. If you want narrow around the population proportion, the actual, you want a lower level of confidence. And this is where things become counterintuitive, because you would think that when we say confident, that you've captured, the population proportion. I think we just lost
Hit
it.
freeze for you guys.
Are you guys still there? Y'all still there?
What happened to his Wi-Fi? Oh,
I think, I don't know if it's y'all still good?
Yeah,
Yeah.
Yeah, we're good.
Okay. All right. Everybody still good? Questions on this one we just did? Boom.
Good.
All right. So just remember what confidence means. It all depends on what we want. If we want a narrow interval, we want a lower level of confidence. If we want a wider interval, we want a higher level of statistical confidence. Confidence in this context should not be confused with confidence like whatever. I'm confident it's gonna rain tomorrow or something like that. Okay. Or I'm confident I'm gonna do well on the exam. That's good. I want you to be, but that's a different type of confidence. Okay. All right. If we're good on this, I think we have one more. And so, Nick, we haven't used the T-table yet. I think I might be letting you down. Let's take a look at this one. This is this might be kind of difficult. All right, Nick and Brooke produce tables.
Wait, we can't see the screen. Oh, and unless it's just me.
What do you think?
No, I can't see it
Can't see
either.
it.
Oh, thanks for letting me know. We good to hook now?
Yep.
Yep.
All right,
Yes,
super.
sir.
Okay, so Nick and Brooke produce tables. This is not modeled after Nick Hager. This is actually modeled after Nick Olson, who is a member, a former D3M warrior. Anyway, sorry. Get kind of emotional, choked up there. As well, Brooke Adesu, you know Brooke, Travis. So this is modeled
Yes.
after him. Their process follows a normal distribution. Okay, cool. If their process is working correctly, only 3% of their tables are defective each day. So let's just stop there. What do we think that might be? What do you think, Travis?
I'm going to say, are you asking for like the type of problem?
Yeah, even simpler. What do you think that 3% is? So if 3% are defective, 97% are not defective. So what is that 3%?
3% are the ones that they don't work.
Yeah,
Like-
they've got a scratch on
Yeah.
them or a leg that's shorter than the others. But
Mhm.
what type of variable is defective?
I'm not sure.
What do you think, Nick? Is this a numerical variable?
I really don't know, to be honest.
Okay, let me ask a simpler question. What type of variable is it when I have a bunch of women and I ask them, are you pregnant or not? What type of variable is that? They're either pregnant or they aren't, right?
Yeah.
Okay, so what type of variable is that? Is that a numerical variable? Or is that a categorical variable?
Categorical.
Right. It's yes or no,
Mhm.
right? There's no 56.72. Either a table is defective or it isn't. So what do we think this 3% is? Delaney?
Numerical.
Well, it looks like numerical, but it corresponds to the amount of defective tables.
Okay.
That's
So this
basically saying like
is
it's the no. Yeah.
this is a proportion.
Okay.
Okay, and the reason I'm dragging you through the mud on this kind of what is this is so that a couple of things burn to your brain. Categorical variables usually result in proportions. Okay, numerical variables result in means. X bar. This is P. Okay, Nick, did you eat eggs today or not? Did you eat eggs for breakfast?
Nope.
Yeah, so it's a categorical question. It's a categorical variable. Travis, did you have eggs for breakfast?
No, I did not.
Yeah, so categorical. All right, Delaney, do you have eggs?
Nope.
Yeah, that makes 0 out of 4. So our P is 0. All right. Okay. Now, if I asked you, Travis, how many calories did you have for breakfast? That's a numerical variable, right?
Yeah.
And Nick and Delaney, and I could take an average.
Mhm.
See what I mean?
Yeah.
Okay. So again, when I see a categorical variable, it probably corresponds to a proportion. Okay. And it doesn't have to be yes or no either. Travis, would you rather have eggs or oatmeal for breakfast?
I haven't had oatmeal in a while. Oatmeal, definitely.
You get the idea, right? It's
Yeah.
this or that, yes or no. And really, yes or no is kind of a this and that in disguise. Okay, let me get rid of all this mess here and get back on track. So this 3% right here is a population proportion. Okay? Nick and Brooke
Mhm.
have this process, and the population proportion is supposed to be 3% or less of defective tables every day. That make
Mhm.
sense?
Yeah.
Okay. All right. Well, let's see what else we got. Today, Nick and Brooke inspected a sample of 30 tables and found 2% of them to be defective. So, Nick, what type of problem do you think we're looking at here?
Well, it still would be categorical.
Okay. So, but what, in terms of our 3 big chunks of
Oh.
problems, what big chunk of problems do you think it is?
Is it a sample?
Yep. And it's dealing with what type of sample?
A sample proportion.
Yeah, very good. Okay,
Is it
so
not?
we know we're here and we're going to be dealing with this. All right, and we found that P is 2%. So Delaney, how should we write? If we're going to say P is equal to something, how would we write that? Would we put 2 here?
It'd be 0.2, right?
0.2 would be 20%.
Oh, 0.02.
Yeah.
0.02.
Everybody tracking?
Mhm.
We got to be really careful because if we put 0.2 there or we put 2, we're going to be lost in the sauce. I mean, we're going to be soup sandwich. Can you visualize soup sandwich? Mess.
Nasty.
Nasty. So, got to make sure we get P correct. All right. So we're here. We're dealing with this. We have this. This right here is that. P-pop. Okay. And while we're at it, Travis, what is N?
And should be 30.
Very good. Okay, cool. So if this process is behaving as it should be, what is the probability of 3 or more defective tables within the sample? Okay, so first let's draw. Nick, what value goes right here in the middle?
3. No, it's not. Is it 30? Is it?
So close. So close. Get closer.
0.03.
0.03. Okay, that's the proportion of the population for this process. Okay. Sometimes it's a little less, sometimes it's a little more. Follows a normal distribution. Okay. So we have the sample is over here somewhere. Okay. That 0.02 is over here. And we're trying to figure out, actually, 2% of them defective. What is the probability of 3 or more defective within the sample? Okay, so actually,
Is it the other way around?
now, trying to remember what I was thinking when I wrote this. These are different questions. So based on this one right here, if the process is behaving as it should, what is the probability of 3 or more defective within the sample? So we're trying to see the value, the probability of a certain P. What is that P? How do we determine? So if we say 3 are defected within the sample, what is P? How do we determine that? What do you think, Delaney? We got to do something with that P.
Yeah, would you use the equation that goes with that, or?
Well, first things first, we got to figure out what P is. What
Okay.
equation are you talking about?
I was thinking the one for sampling the Z equals, or no, I'm sorry, the X bar equals Z times sigma divided by the square root of n plus m. But
Yeah, see, we're dealing with proportions, so we've got to stick to those. We're still sample and P. So sample or P equals X divided by N. And if 3 are defective within the sample, there's 30 here. P is equal to 0.1. So this line shouldn't be here as I drew it. This line for 0.1 would be somewhere over here. And we want to say 3 or more. So we're trying to figure out what the probability that corresponds to that area right there is. Okay. So first things first, we need a Z-score. So Nick, how do we determine that Z-score?
K-take? No, that would make sense. Never mind. Are we going to be doing 1 minus something to get the Z-score?
Eventually,
Yeah.
you guys still there? Man, my internet's flaking. All right. We still good to go? My internet connection is still unstable. All right.
Would you do 1 minus? Would you do 1 minus 0.1 or no?
Not yet. That 0.1 is P.
Right.
Okay. So does this look familiar?
Okay.
Okay.
Hmm.
So let's go ahead and I'm going to write that up here. Z would equal 0.1 minus 0.03 divided by the square root of 0.03 times 1 minus 0.03 divided by 30. And then once I get that value, I would do a 1 minus with that. Anybody got this calculation?
I'm doing it right now. Okay.
Mine says undefined.
I got 2.24, 2.247.
But,
2
oh,
point.
yeah, that's why.
That's what you got?
Yeah, that's what I got.
2.24.
It's I got 2.24756. So you guess you could say 2.7, 2.248.
Okay, so that would be 0.9875. So I would take that 9875 and that'd give me something like 0.0 something. 0.02.
125.
Is it 125?
Yeah, one.
Should be.
Okay, so this value right here is what
point. Yeah,
that
point.
equals. All right, so which is a 1 point something percent.
Mm-hmm.
Okay,
Right.
so I don't know why I wrote that there. So if Nick found 2 defective tables in the sample, should they shut down the production process? What do you think? What's anybody think?
No, they shouldn't, because that wouldn't equal 3%, because it's like at the beginning we see, right, the 3% are defective each day, but why would they shut down if they only had 2 defective? Wait, I would have to do the percentage 2%.
You're on the right track. The bottom line is we just did the probability of 3 or more.
Right.
Mm-hmm.
Okay, so the probability of 3 or more is very low. So if they only found 2, then we could do this again and do it for a probability of 2.
Yeah.
We would say 2 divided by 30 and whatever that new value of P is, and we could determine that probability of that happening.
Mm-hmm.
Okay, so that 2 would probably be somewhere back in here, that a high probability of 2 being defective in the sample. You're on the right track of thinking. So 2 divided by 30 is 1 divided by 15.
Right.
Which is less than 3%, I think.
I think so.
Okay. All right. I think we're about 1 minute out on time. Nick, we didn't get to the T table, but let me just give myself a,
Well, what I'll do is, because I'm gonna spend like the rest of today and then before we take our test tomorrow, just trying to crank out for like a bunch of different problems, of stuff that you have on Canvas and everything. So, um, yeah, I'm just gonna do that, just so I understand what I'm doing.
okay. Let me just write this up here real quick. So when we're talking about the T table, all right. First of all, the T table only comes into play when we're doing confidence intervals.
Mm-hmm.
All right. If we recognize that we're doing a confidence interval for proportion population, we don't need to worry about the T table because we're going to use Z.
Yeah, like we just did before.
Yep. The time that we need to worry about the T table is when we're doing a confidence interval for the mean. And even then, we need to ask ourselves, do we know the population standard deviation or not? Okay. If we are down here,
That's when we use the T table.
yep. And to use the T table, we need to know two things. One, degrees of freedom, which is equal to n minus 1. And two, what is the other one? What's the other thing we need to know? What do you think?
I know you wrote it down too. I literally just looked at this too, like the one you created on there.
We need to know alpha half. Okay. And those two things, once we know those two things, we're going to go down here. Let's say degrees, let's say n is 12 and alpha half is 0.005. Well, if n is 12, then degrees of freedom is 11. So I'm going to go down here to 11 and I'm going to go across and keep looking for 0.005. And right above my cursor there, 0.3106, I'm going to use that value for T. Okay. So if I have a problem, and the standard deviation is not specified, or I'm kind of going into uncharted territory, like things with the coronavirus, where how could anybody know the population standard deviation, or excuse me, the standard deviation of the population? Most of the time, if I'm up here, it's because an expert has given it to us or something like that. But in my mind, this is much more realistic. Okay. So really the trick, Nick, is the process.
Okay.
First, hey, am I here? And that's why I teach it this way, because I want you to have all these checks.
It's
Am
like
I here?
steps,
Yes
right?
or no? Am I here? Yes or no? Am I here? Yes or no? And once you're confident that you're here, then it's just a matter of procedure.
Okay.
Make sense? Does that help?
Yeah. No, that makes sense. I just didn't. I kind of like when I was doing the formula sheet, for example, like I said, I know that you put this on the Canvas, for example, with like the steps of knowing when to use it. I just, because I hadn't done one, so that's why.
Yeah.
Or I had done it wrong, that's why.
All reps matter. So you guys continue to rep out quality reps, okay? And when you make a mistake, the most important thing is, hey, what did I do wrong? And then how do I prevent myself from doing that in the future? Okay. So it's not so much, hey, did I get the right answer? If I did something wrong, I need to make myself bulletproof against doing that in the future. And I have ways in which you can do that. But once you figure out the way that you can prevent that error in the future, your money, man, your money, then you probably won't. Okay. All right. So with that, I'm going to let you guys get after it. Any other quick questions before we go our separate ways? Good. Feeling good?
Yep.
Better. Thank you.
All right. Yeah, you guys bet.
Thank you very
You
much.
bet. I wish you the best. Continue to rep out. If you have any questions, come up on email and we'll work through them. All right. Have a great day.
Thank
I'll post
you.
this.
Thank you.
I'll post this and send you the link and all that good stuff.
All right.
Okay.
All right.
Thank you again.
Yep. You guys take care.
All right. See ya.